With ever greater concerns about global warming, the world's shipping industry is facing a major challenge. If it were a country, it would be the 6th largest producer of greenhouse gas emissions.
At current growth rates, if we do nothing, those emissions could double or even triple by 2050. So is there anything we can do about this? The good news is, yes, there is.
A global industrial revolution is underway.
Yes, we have a technological challenge for our environment, for the well-being of the population of the planet, for civilization.
Driven by passionate, dedicated individuals intent on shaping a new world.
I do it because I look at my kids, and I honestly am convinced that this is the way.
A cleaner world.
There is a way forward other than burning fossil fuels out of our funnels.
A greener world.
This wind farm is producing more hours of power into the grid than all wind farms in the UK and probably in the world.
What we've done in the past is not going to solve these challenges. We need to find new ways, and I think the only way to do that is to bravely step forward and implement technology.
Together, they are pushing engineering to its limits. To create extraordinary machines that can protect our planet for the future. Gavin Allwright represents a growing number of technology developers, shipbuilders, and operators intent on reshaping the future of global shipping by harnessing a resource that has transported humankind for millennia.
So it's strange, when we look at wind farms or wind turbines, we see those now as modern renewable energy solutions. But when our mind's eye turns to wind-powered vessels, we think of that as being old-fashioned. Now, there are still traditional sailing vessels out there delivering cargo, but there's a whole new breed of naval architects, designers, who are using cutting-edge technologies to power the vessels of the future.
This is Black Pearl, the world's largest sailing yacht. Many in the shipping industry believe she could form the blueprint for a new generation of commercial sailing ships. It's been 2 years since this extraordinary vessel took to the sea, and having proved herself on the world's oceans, she's returned to Holland where she was built, for what can best be described as some fine-tuning.
It works well, but having said that, one of the reasons we're here in Amsterdam is that we're tweaking, we're improving, because we believe we can make it better.
Chris Gartner, skipper of Black Pearl, appreciates more than most the ancestry of this 21st century sailing ship.
The inspiration comes from the clipper ships, for sure. The Cutty Sark or the Stad Amsterdam, the high speed that they traveled, super efficient using the wind.
To give some idea of just how efficient these clipper ships were, we need to look no further than the Flying Cloud. In 1854, she set the world record for the fastest passage between New York and San Francisco, 89 days, 8 hours. That record stood for 130 years. It was only surpassed in 1989. And this was a vessel with no motors or engines at all. Large wind vessels were still operating right up until World War II. These ships were seriously fast. Some of the clippers could exceed 20 knots. Many modern ships don't do that.
The old sailing ships did require a large crew. On deck, they'll run with about 16 people, and they can drop all their sails or set their sails in approximately 25 minutes. Then carbon fiber came, and the game changed. Voila, we come with the dyno rig. We can maneuver the boat at sea with one person.
The dyno rig system utilizes rotating masts to achieve the optimal position for its square sails. First conceived of in the 1960s, it was not until 40 years later that there were materials strong and lightweight enough to be up to the job. Towering 232 feet above the waterline, Black Pearl's 3 enormous masts are the largest example of the system by quite some margin.
They are built to be freestanding, and they're like a big carbon fiber fishing pole. We carry 2,900 square meters of sail area, which we can deploy in just over 7 minutes, but more importantly, we can furl them away or close all the sails in just under 7 minutes.
Being able to react quickly to changing wind conditions makes for more efficient sailing and greater energy saving. And what's more, it's all done by remote control.
Basically, you have to take 3 big, deep breaths before you really start exerting your finger. No, but it's as simple as that. What does it feel like when we are sailing this boat? It's incredible.
Just over 24 knots is our max under sail so far. The prediction is with the right winds and stuff, we should reach 28, 30 knots.
Which is the equivalent of over 34 miles per hour.
Well, I think we had a classic example on our very first voyage from Rotterdam down to Gibraltar, where one of the Portuguese coastal stations called us up. Black Pearl, can you please confirm that you are a sailing vessel? Yes, we are a sailing vessel. And there was a slight pause there, and then there was this Black Pearl, are you actually sailing? Yes, we are actually sailing. And at the time, we were doing 22 knots, I think it was, and passing all the cruise ships, the container ships, and the tankers and motorboats, and they just couldn't believe it. That was a great trip.
But the designers of Black Pearl were determined to take things a stage further. When under sail, the propellers of the ship can be used as underwater turbines, generating electricity.
Let's have a look in the engine room. This is our main engine, our starboard main engine. Attached to this is the gearbox, and on over this side, our electric motor, which gives our electric propulsion when we want to drive off batteries. So we have the option of running on diesel or electric, or a combination of both, which gives us our maximum speed. So obviously when we're driving the boat, the propulsion is that way. When we're sailing and regenerating, the power comes back through the shaft into the electric motor here, and is then distributed to the AC distribution board at the front of the engine room. And that's how we get our battery power. And here we have the starboard battery room, 240 batteries, lithium-ion batteries. A motorboat, it might do 17, 18 knots as its maximum speed, but majority of the time a motorboat is cruising at 12 because that's the optimum for fuel consumption and everything else. So for us to be able to do that and regenerate and not use fossil fuels is very cool.
Currently, the team are looking to add solar panels either to the superstructure or flexible ones in the sails. And the ship has already been pre-wired to accept both options.
I think the ambition right at the beginning was to be the first and set an example to our industry. And commercial shipping is taking it very seriously.
Beyond yachting, the dyno rig can move into the commercial side of shipping. There's already many studies done for having multiple dyno rigs placed on large ships.
And a sailing boat can go everywhere a motorboat can go.
just nicer, quieter, and no pollutions.
Now, the good news is the International Maritime Organization, the IMO, has set an ambitious target to reduce greenhouse gas emissions by at least 50% by the year 2050. Now, some shipping companies have gone beyond that with more ambitious targets to be carbon neutral by that year. But to make it happen will require a radical transformation. Let me give you a few shipping facts to set the scene, to show where shipping is at the moment. Over 90% of world trade is carried across our oceans by anywhere up to 90,000 large ships. The fuel burned by many of these ships is called heavy fuel oil. That's a toxic sludge that's highly polluting. Shipping, however, is the most efficient way of moving large quantities of goods around the world, by far. Now, obviously, we can't change things overnight. So we need to be looking at transition technologies, ones that take into account that very few people have retained those skills to operate traditional sails. We need to be looking at modern solutions.
Just 40 miles away from where Black Pearl is currently moored lies the Marine Research Institute, Netherlands, better known as MARIN. It's a world-renowned organization which for over 80 years has provided the maritime industry with expertise and independent advice. Today, they are at the forefront of research into sustainable marine propulsion.
One mistake that many people do is to think that the wind is pushing a sail, and that's why it's hollow, and that's why you're going forward. Actually, it's working with suction, not with pushing. The wind is blowing. You have a flow coming on a given object, and this object is diverting the flow and creating on one side a high velocity and on the other side a lower, smaller velocity.
It's known as the Bernoulli principle, after an 18th century Swiss mathematician called Daniel Bernoulli. He discovered that the faster a fluid flows, the lower the pressure. It's why a wing creates lift on an aircraft. The shape of the wing makes the air flow at a faster speed on the upper surface, creating lower pressure and effectively sucking the wing upwards. In the 1980s, designers began experimenting with rigid wings on boats.
So it started with simple, smaller sails in area, but with a metal rigid profiles. And then some engineer pushed the idea further and only looked at the way a lifting surface is working.
Collaborating with the famous undersea explorer Jacques Cousteau, two French engineers came up with a rigid sail which had a perforated outer surface and inside a fan, which created suction affecting the boundary layer. This amplified the pressure difference and increased the lift effect, making it 4 times more effective than the best conventional sails of the same size.
And people who are looking at traditional sails cannot believe that a pillar, just a round thing, can produce lift. But it's a very smart and very powerful system. And then this invention was just left on the side and never used again. 5-6 years ago, we made presentation to try to revive the idea because we were believing that was a very smart system. And my hope was that at least one person in the room would raise his hand and say, well, this is a nice idea, I will pick it up and apply it on ships.
One man who did just that was Frank Neuwenhaus.
We first started on scale models. The first one I took on top of my car in order to see if this suction is actually working. There's quite some technology to combine an airplane wing, which is only the wind always comes from one side. And in sailing, sometimes it comes from one side, sometimes it comes from the other side. Also, the suction technology is quite difficult, and we needed to get that all in the right balance. And of course, all of this we wanted to get ready as quickly as possible.
What they really needed was access to an immensely powerful computer able to handle the hugely complex calculations associated with airflow and pressure. Luckily for them, just such a computer is to be found at the Marin test facility.
We have been working with them on calculations to further optimize the profile, the amount of suction you should apply to boost the performance, the effect of the height of the cell.
And then they studied how does this suction work, how does the angles work, and what is the right shape, and they've been extremely helpful.
But even with access to a supercomputer, you still need to conduct physical experiments. And if a car worked for a small model, there was no reason not to try it with something a little larger.
Our approach is to have a little bit of saving on many ships. And we try therefore to make systems that can be installed on the ships that are already out on the sea today. We don't have to wait to build new ships. And if we want to save quickly in shipping, we have to install something fast and easy, things that are produced on an industrial scale that gives you a result. One of the key issues of this wing is that this big ventilator is sucking out the air from the wing, and by that influencing the airflow around the wing. And it's done through these little holes here, which run all the way through the wing, and this ventilator just expels the air and throws it outside in the bottom, creating vacuum in the wing and influencing the airflow around the wing. So one of the most challenging things, really, is to get this big ventilator, 2,500 kilos of steel, inside this wing construction. And it has to be glued in and connected to the bolts here. And once it goes in, we only have 10-15 minutes before it has to be perfectly aligned.
One of the first ships to adopt the system is the freighter Enki.
You can push the start button and it will sense where the wind is and it will position itself correctly relative to the wind. This wing can actually tack, as they say in sailing. So depending if the wind is on the left side or on the right side, we change the shape of the wing and the boundary layer is being sucked away from the other side. And if you suck away this boundary layer, then you influence the rest of the airflow.
And with the sails in operation, the captain can reduce engine power and still maintain the same speed.
When the ship changes direction, the wings are following the change of the direction. They will always keep the same heading towards the wind. So the captain doesn't have to do anything other than to decide he wants to sail or not.
The system's already proven itself to be both rugged and effective. From the tempestuous seas off the African coast to the Arctic conditions of Northern Europe.
Best as any sailor knows this, that when you have half wind, so the wind comes from the side, then the effect of wind propulsion is the best. But when it's from 25 degrees to about 180 degrees, it works.
But Frank and his team weren't finished there. They had the idea to make something altogether more portable.
So, this is where the magic is going to happen. This is the container. There will be one wing here, and there will be one wing down here, and in the end they will open up and start saving fuel.
This is the MS Royale, a container barge plying the route between Amsterdam and Harlingen.
So what happens is, with a normal crane, they put the container on the ship, and then we press a button and the wings flap out. So at that moment it's already installed.
Which means that any ship with the space for a container could theoretically install a system quickly and easily. The team at Econowind estimate that in optimum conditions, a ship could reduce fuel consumption by as much as 25%. However, as the wind is not always consistent, they predict a still impressive average saving of around 10%.
In maritime sector is pretty conservative for good reasons. I mean, the sea is a very harsh environment, so it's difficult to introduce innovation in the maritime segment. So I'm extremely happy to see that this very smart invention is now applied again on board ships.
And we're actually discussing now about a system. It will be 20 meters high. One wing will be about 2.5 times the total force of the 2 wings which are in the container.
What we need for wind propulsion to be taken seriously is not just 1 or 2 companies out there doing it. We need a vibrant, thriving industrial base with many companies delivering many new technologies.
This is the MV Copenhagen. Together with her sister ship Berlin, she operates on the busy route between Rostock on Germany's Baltic coast and the Danish port of Gaza. Built in 2016, they're 2 of the largest hybrid ferries in the world, able to carry 1,300 passengers and 460 cars.
Well, welcome to the battery room of the hybrid ferry Copenhagen. A hybrid ferry is a ferry that has a battery system installed to supply energy when it's needed and to store energy when it's not needed.
Scanlines estimate that their hybrid systems reduce CO2 emissions by up to 15,000 tons a year, the same amount as produced by over 340 average German households.
And the journey doesn't stop here. It is our overall ambition to operate zero-emission ferries, but due to the energy requirements for a 2-hour voyage, it is much more complicated, and it's all of the small things that add up.
As efficient as she is, Copenhagen wasn't originally designed to make use of the free and abundant energy that wind provides. But tonight, all that is about to change. Once the passengers leave the ship, she'll make her way to the nearby dock and be fitted not with a sail, but with a device first conceived of over a century ago, which works on a principle known as the Magnus effect. The Magnus effect gets its name from a German physicist named Heinrich Gustav Magnus. In 1853, he was investigating the reason why spinning objects traveling through the air, such as a spinning ball, don't move in a straight line, but actually follow a curved path.
So what you have, for example, on a football, you have a forward velocity of your ball, which is rotating, and the flow sees 2 patterns. On one side, a high velocity, on the other side, a low velocity, so a lower and a higher pressure, and through the pressure difference, you have a side force. And that's why, with spinning a ball, you can give a certain trajectory. If you take a mast, a vertical cylinder, which is rotating in wind, you will have the same effect.
In the 1920s, a German aircraft engineer named Anton Flettner, with a little help from a certain Albert Einstein, came up with the idea of using just such a device to propel a ship. By 1924, they'd retrofitted a schooner with 2 rotors driven by an electric motor, enabling it to travel at 10 knots. Having proved the concept worked, they went on to create a 3-rotor freighter. But the Great Depression, an abundance of cheap fuel, and no pressure on carbon emissions meant the idea was all but doomed for decades. But there was one legacy. Even today, these spinning cylinders are still called Flettner rotors. It's just such a device that's to be fitted to the Copenhagen. But this mega rotor is twice the size of those originals. Standing 98 feet high and 16 feet in diameter, it's built by Norsepower, a Finnish company who specialize in this technology.
It's an exciting day, even with careful planning for months. There's always something you can't perhaps see in advance. One angle to it is that we have people speaking 3-4 languages and people from 3-4 nationalities working together here.
The reason why Copenhagen and Berlin are the perfect ships for this, and in this case we are trying it out on Copenhagen, is because our ships are trading north-south and the predominant wind is westerly wind. So the wind, to have the best result out of a rotor sail like this one, the wind should be perpendicular to the direction of the ship. So it is the best conditions to test something like this.
But for the system to be effective, it must be commercially viable. Such a valuable financial asset as a large ship cannot afford to sit idle while engineering work is carried out. Even now, trucks booked to travel on the Copenhagen the following morning are already driving across Europe to meet her. For the installation team, it's going to be a race against the clock. To enable the operation to be completed as quickly and as efficiently as possible, the team from Norse Power have already installed the steel rotor foundation along with the control system and power supply.
With this massive piece of equipment, we need to be extremely careful that everything is done right. I had a long checklist that I went through line by line to make sure that everything is correctly attached.
Weighing 42 tons, precision is vital. The placement of the rotor has to be millimeter perfect to enable it to fit correctly to its foundation.
The rotor produces such massive forces that it needs to be connected with 100 really big bolts.
It's a job that can only be undertaken by a crew working inside the rotor. These bolts will need to cope with the 300 kilonewton force the rotor could potentially generate. That's the equivalent of the pressure of over 30 tons being acted upon by gravity.
We are extremely excited to finally see this project become a realization now. And to me and my colleagues, this is a way of really showing that there is a way forward other than burning fossil fuels out of our funnels, because it's extremely visible.
The team will now work through the night connecting the electrical system and tightening bolts. And tomorrow, the testing will begin. If successful, it could mark a new era for Scandlines, whose combined fleet transports 7.5 million passengers and over 2.5 million vehicles every year. But the team at Norse Power are well aware that many other shipping companies around the world will be taking a very keen interest. But some ports present certain challenges to the concept, challenges that must be overcome if Flettner rotors are going to be adopted universally. At a test facility on the windswept coast of northeastern England, British company Anime have developed a system to address just such problems.
The Anime journey began over a decade ago with an environmentally driven ship owner and a group of shipping professionals who embarked on a mission to develop technology that would benefit the industry through reduced emissions.
It was a program that would take place across the world and involve extensive investigation into the way wind flowed around a ship's infrastructure. It was during this period that a renewed interest in the potential of Flettner rotors began, and work was undertaken to develop an automated system compatible with the demands of 21st century shipping.
The initial testing involved scale model testing with use of wind tunnel and 25:1 scale models at Southampton Warsash Academy, where actually the scale model vessels managed to reach a speed of 17 knots with no engine power on the lake tests.
It was an invaluable proving ground. This renowned training facility attracts ship's captains from around the world because the handling characteristics of these large models perfectly mimics their full-size counterparts. Having perfected the theory, Anami's decision as to where to put it into practice certainly can't be described as the easy option. They chose the bulk carrier market.
When developing solutions for these ship types, the crane operations govern so much, so having a large static structure on the deck of the ship would not be an idea that you could sell to anybody.
A folding rotor was one of a number of options developed, and being able to test prototypes such as this one for prolonged periods of time has provided a wealth of essential performance data.
The maximum RPM of this particular rotor you can see in the background is 450 RPM. Now, the relationship between wind speed and rotor RPM is quite important in terms of the performance. The surface speed of the rotor typically has to be somewhere between 3 and 5 times the wind speed. That's pretty much the general target.
But the owners of the 64,000-ton MV Afrost needed something even more flexible. They needed the ability to actually move the rotors.
So we developed a new solution which enables the rotors to be transported along the deck, forward aft, to avoid cargo operations.
The system employs a series of trolleys on rails. When the ship is loading or unloading, the rotors can be moved into positions which best suit cargo operations, whether that be offshore or in port. Upon leaving, the rotors are then moved into their operational position and mechanically locked onto the deck.
The system is very easy to operate for the crew on board. The system takes care of most facets of the operation, including starting and stopping, choosing what rotational speed to go at, which direction to rotate in. Effectively, the crew can turn the rotors on leaving port. The control system will take care of everything. So for the crew, it's a very simple task. So Flettner rotors provide most thrust in stronger winds. So our rotors have been designed to operate safely in wind speeds up to 35 meters per second, which is a very strong wind. They have also been designed to operate in heavy weather, so when the ship motions are quite large. The wind direction also plays its part, and the ideal wind direction is from the beam of the vessel, so coming from 90 degrees or just behind. In those conditions, strong winds from the beam, you end up with very high fuel savings.
And savings in fuel means a corresponding reduction of emissions.
We believe that the savings can be anywhere between 5 and 30%, depending on a number of variables. I think in shipping, as you've seen with the wind industry and the wind turbine industry, bigger is proving to be better. But with ships, there are limitations on operation, so there will be a ceiling of where you can go with wind propulsion. But I don't think we've reached that ceiling yet.
Back in the Baltic, the new silhouette of the MV Copenhagen has been drawing much attention in the shipping world. The rotor installation was scheduled to be completed in just one night. With the ship needed in service the following morning, there was no margin for error. Remarkably though, the team was able to meet this ambitious target with room to spare.
It didn't last more than, I would say, 10 hours or so. Then the rotor was on, bolted, and we could go again.
At the moment, it's the height of summer when the prevailing winds are at their lightest. But the crew have wasted no time in testing the system ready for when the winds become stronger.
Of course, the idea with this rotor is that it's fully automatic. So normally we do not have to do anything. It just runs in the background. We have done some testing to prove the efficiency. On a cruising, we have been stopping the rotor, see what will happen. And we realized that the ship speed went down with half a knot. Then we started again, and we gained the half a knot. So it actually works.
We still need to see the good season for it. But we have already seen promising results. With the installation of this rotor, the expectation is that we will save up to 5% on our fuel oil. But a 5% fuel saving is also a 5% emissions saving.
Although the rotor may be huge, its control panel is remarkably small. It not only automatically controls when and how fast to spin the rotor, but it also provides valuable data about all aspects of its performance. But how has such a large addition to the superstructure affected the ship's handling?
We feel a little difference. It's not much. We can see when the rotor starts, then the ship will heel a little. In high winds, it will heel more, up to 2 degrees, we have seen. So the one thing we have to do every time the rotor starts is that we have to move some ballast water. So for our customers, they will not notice because the ship will always be even keel. And we can see when we have high winds in Gedser, our smallest port, we also feel that we have to work a little more with the maneuvering.
In the same way that a wheel of a car requires balancing to avoid vibration, so the giant spinning rotor has required a little fine-tuning as well. But that has been finally completed today.
Now when we have made the last corrections, that makes it possible to run even faster, the most optimum speed with the rotor.
We acknowledge it's a technology that has been around for 100 years, but so far very few commercial operators have had the courage to actually try it in a live environment. We sincerely believe that we are in the right spot. We are the right size of ship to make this a success. I can't explain how thrilled I am to be given the opportunity to run a project like this, and to be allowed to do things that are good for the environment. It's good for the company as well, and it draws a lot of positive attention, we have to say. It is fantastic in all respects.
But it's not just how ships are propelled that is currently undergoing a revolution. It's also where they sail and when.
In the 21st century, we have advantages that even 50 years ago would have been unthinkable.
By making use of ocean currents, it's possible for ships to make significant energy savings. But how do you monitor these ever-changing currents in real time in order to be of use to ships' captains?
So our system is about measuring ocean surface currents by observing how the vessels, ships are behaving, or they move around, and we do that by analyzing marine traffic information. So every single commercial vessel has a beacon which broadcasts real-time its position, its speed, and some information. It's called AIS, Automatic Identification System, which is to avoid collision between vessels. We utilize 120,000 vessels continuously sailing around the world and sending their position every 2 minutes. And this information is collected by some telecommunication satellites, and we get this data into our server and with our processing system. So we learn with some machine learning algorithm from the way the vessels are behaving, and we deduce the ocean current that the vessels are going through.
And with access to accurate information about currents, ships' captains can alter course to either avoid adverse currents or take advantage of favorable ones. It's estimated that if applied to shipping globally, it could reduce fuel and emissions by 5%. However, on some routes, those savings can increase to as much as 15%. And this is just on conventional powered ships, without taking into account the additional benefits that wind-assisted propulsion would bring. But for global industries which have grown used to a just-in-time delivery of parts and materials, there are still huge questions to be resolved if we are to achieve a new, greener future.
What if there's no wind, or the wind's blowing in the wrong direction? Well, in that case, we need a hybrid approach.
This is Energy Observer, a French vessel which is halfway through an extraordinary 7-year odyssey.
Energy Observer is a floating laboratory. The idea is to test different technologies constantly and improve them, and to work hand in hand with the maritime industry to help them find ways to limit their impact. It's also a media boat, so the idea is to be able to communicate and educate people about renewable energy everywhere we go. So the boat evolves all the time. It's a work in progress.
The project is the brainchild of master mariner Victorien Erissard and journalist, filmmaker and explorer Jérôme Delafosse. And the boat, reflecting the ethos of the mission, is of course recycled.
Energy Observer was built in 1983 in Canada. Her first name was Formule-Tag.
And it was one of the first big racing catamarans. And it's basically a boat that we completely refitted. I mean, the boat was a wreck when we got it.
Turning a racing machine into a laboratory meant doubling its weight to 30 tons, which in turn required putting in extra foam to keep it afloat. But it was necessary as it gave the boat the ability to install, test, and adapt a wide variety of technology. But as with all experiments, it's often as useful to see what doesn't work.
For example, we try the vertical axis wind turbines, and I think it's not a solution for this type of ship.
Other things have worked so well that the decision was taken to increase their use.
At the beginning, we had only 100 square meters of solar panels, and now we have more than 200 square meters.
The good thing about Energy Observer is that they're prepared to try new approaches, new technologies that may not be ideal for them, but could be solutions for others.
The kite system is a solution, but it's not a solution for us at the beginning because we sail along the coast, along the European coast, and is a solution for the offshore navigation, for example, when you cross the Atlantic. And after, we want to try another technology, and it's impossible on this ship to keep all the technology because after the weight is too important.
While kite sails may not have been ideal for the energy observer, they are being tested on larger ships. One benefit being that they're an off-the-deck system. An off-the-deck system means they don't take up valuable deck space, which could be very beneficial for things like container vessels.
Having now been fitted with highly efficient rigid sails called ocean wings, Energy Observer can use its propeller and electric motors to generate electric power while sailing, much like Black Pearl. However, what has got so many in the maritime world excited is what they do with the electricity they generate.
With that energy, we take seawater, we desalinize it, we demineralize it, then it goes through an electrolyzer, which divides the molecule of water into H2 and oxygen. The oxygen we let go, and then we'll be compressing the hydrogen in 8 tanks, which are at the front of the boat.
And this ship, Energy Observer, she's the first ship able to make her hydrogen on board.
Working with Toyota, they installed a new highly efficient hydrogen fuel cell, which uses the hydrogen they create and store to produce electricity, which can then be used to power the electric motors.
The maintenance of this type of technologies are very, very easy. You don't have oil, you don't have noise, you don't have fine particles everywhere on the ship, so it's very clean. It's really the future.
When we started Energy Observer, the maritime industry was kind of laughing at us. I mean, they were like, yeah, whatever. I mean, this is just, it's peanuts, it's never going to work. But because we've proved the energy mix that we've implemented on the ship works, they're really interested. And now they're like, oh, so how can we implement, how can we have hydrogen on board? How can we add solar panels? How can we reduce our emissions by using the ocean wings, for instance? So we're only at the beginning of this phase, but it's very, very exciting.
So successful has this project been that it spawned Energy Observer Developments, which is creating a range of commercial applications based on lessons learned. From hydrogen generators to floating green hydrogen fuel stations. But the crew know from first-hand experience, it's a race against time and one that none of us can afford to lose.
When you see the glaciers, it's absolutely breathtaking. But at the same time, you know that the polar bears are all dying, that the glaciers are all melting. So you know how fragile they are because they're all disappearing as we're exploring.
Thanks to the efforts and research of just such pioneers, there are now many in the shipping industry that are daring to believe that the next decade could be one of transformation.
So a lot of people ask me, is this really going to happen? Is this not just a fantasy? Well, my answer to that is it's already happening. Year on year, we're seeing momentum growing, a doubling of installations every year, and that trend is set to continue.
Really, it's not only a transition, an energy transition pattern, but it's really a revolution. So we are going to see new type of ships, but what people will mainly see, I think, is the fact that large wind power device will be installed on board ships. The bigger the better. If you want to catch a lot of wind, you will need at the end quite some area. There might not be sails like the Cutty Sark, but I think this will be quite welcome by everybody to see sails again on ships.
Can wind do the heavy lifting on its own? Of course not. Alternative low carbon and zero emissions fuels are really going to be necessary too.
We know that we will need different types of power, so the new vessels will be much more complex, I would say, in terms of design and engineering, because they will have to cope with different sources of energy. You will have to handle them smartly typically with the wind, because the shortest route will not be the best route.
It's been estimated that by 2050, wind could provide up to a third of the energy required by the maritime industry, with some new designs on certain routes getting as much as 80% of their energy from the wind.
Well, by 2050, we could be seeing vessels that have far more hydrodynamic and aerodynamic hulls. The hull itself functioning as a wing sail, perhaps. We will be seeing things like kites and suction wings being standard equipment on vessels.
We need to dare to go ahead at very high pace. So that means also taking risk. But we have no choice. It has to happen, and it has to happen extremely quickly. At this moment, in terms of climate change or loss of diversity and all the issues related to human activity, I mean, it would be hard to make larger mistakes. The basket of solutions that we see coming for shipping will allow to transport goods from A to B on the planet without producing any harmful emissions. And this is a very nice horizon, not only for the shipping, but for all mankind.